Class. Today we're going to begin the second chapter of our probability unit, and that topic or this chapter is entirely about random variables. In the first section, we're going to be going over a discrete random variables and continuous random variables. Today we're going to be going over discrete random variables and expected value and the mean of a discrete random variable. So if we were to look at this presentation, right, the first thing that I'd like to talk about is what is a probability model, and then what exactly is a random variable. So a probability model pretty much just talks about all the possible outcomes of a chance process and like how, what's the chance that each of those outcomes will occur. Now, when you have that probability model, it's like the whole thing. It's everything related to the random variable. And the random variable is just you could say the numerical outcomes of the values that you are kind of interested in. So for example, if you are tossing a coin 3 times, the random variable x, you could say, is the number of heads that is obtained. And the probability is the possibilities of those occurring, right? What's the possibility of tails, tails, tails? Well, it's 1 out of 8. What's the possibility of 1 heads? Well, that's heads, tails, 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 heads, tails, 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 heads, right? The probability of 2 heads would be what? Heads, heads, tails, heads, tails, heads, tails, heads, heads. And the probability for 3 is just going to be heads, heads, heads. The whole thing is the probability distribution, and the random variable is just this value of x, right? All of the possibilities for x. Now, why is this discrete? Is because you can't get a value in between 0, 1, 2, and 3 heads. You're either going to get 0 heads, 1 head, 2 heads, or 3 heads. Those are the only possibilities, okay? So that's why this is discrete rather than continuous. If it was a continuous random variable, the other possibilities for x would also exist, say like 0.5, 2.14, all of these possibilities, but since they don't, then this is a discrete random variable, okay? So today, our main topic is going to be discrete random variables. So when you're looking at the probability distribution of discrete random variable, you get the values for, let's say, x, and then the probability of each of those occurring. Now, the probability, like what are the requirements for this to be valid? The probabilities of all of the values have to all be less than 1. And then they have to add up to 1, okay? Because the total probability of the sum of P1 through Pi has to be 1. Otherwise, it's not a valid probability model. So when you're analyzing, we actually did a little bit of this in chapter 1. I don't remember if you remember this. This was so long ago. But do you remember what the Apgar score was? I'm not sure. Okay. But we looked at this distribution towards kind of the beginning of the year. But we looked at it more in terms of like what is like the shape of the distribution. And this distribution is, skewed to the left with a single peak at an Apgar score of 9, right? Um, so if we're looking at this problem right here, Pete's Jeep Tours, um, yeah, I'll just read it. Pete's Jeep Tours offers a popular day trip in a tourist area. There must be at least 2 passengers for the trip to run, and the vehicle will hold up to 6 passengers. Pete charges 150 per passenger. Let C equal the total amount of money that Pete collects on a randomly selected trip. The probability distribution of C is given in the table. Make a histogram of the probability distribution and then describe its shape. Okay, so if you look at this, right, if he has 2 passengers, right, he's going to collect $300. If he has three, he'll collect 450, 600, so on and so forth. And this is like the probability of each of these scenarios happening, right? There's a 15% chance that there's 2 passengers, a 25% chance that there's 3 passengers, a 35% chance that there are 4 passengers, so on and so forth. So if we look at this probability distribution, right, you'll notice that the graph is roughly symmetric and has a single peak at around 600. Just like the previous page, you can analyze these graphs, these probability distributions of discrete random variables. Now, why do we care about this? And like, what's the most important thing? Is I would say expected value. A side note: expected value is is everything. Um, just in general, right? Insurance companies exist and are able to run because of expected value. Um, you could say like casinos, their businesses are able to run because of expected value. Um, you could say even poker. I'm not sure if I'm allowed to talk about this, but like poker and gambling, the best poker players, the modern poker players of today, they know their plus minus EV for every hand. So their expected value and like what they should do given certain situations. It's all about expected value. So today we're going to talk about what expected value is and like how to come up with it. Okay. So how do you calculate expected value? It should be pretty clear, right? You just take each of the values. It's almost like a weighted average, right? Um, where you take each of the values and you multiply by their expected probability of occurring. And then you add that all up, and that is like your average expected value. So, in terms of like Pete's Jeep tours, right? Oh, I wish, oh man, they didn't calculate it here. Why didn't they calculate it? Um, no, okay. So this is quite annoying because I expected that there would be an expected calculation here. Okay, so I need you to look at this slide and then also look at this slide. Okay, if you take each of these values and multiply by their corresponding probability, so you take 300, multiply by 0.15, add it to 450 times 0.25, add that to 600 times 0.35, and then you take 750 and you multiply by 0.2. Then you take 900 and you multiply by 0.5, and you add them all together. The sum of this should be this. Okay? Now, how should you interpret this? And if you look at it, it's also like the balance point, right? Okay, it's the balance point right here is 562.50. That's the balance point. Okay, so in other words, if you were to put it on a scale, that's where it would balance. In a way, what you would say about this value, 562.50, that is the average amount that Pete should make per trip. Now, is Pete ever going to make exactly 562.50? Probably not. But that is like his expected amount based on, you could even say, long run averages. Like if you were to go according to the law of large numbers and you averaged out all of Pete's winnings, then the average would be 562.5 and 562 and 50 cents over the long run. That is how EV works. That is expected value for a discrete random variable.